Yeah. So guys, good evening. I'm Keshav Gupta, as you know, your TA for DBMS on Let's Learn. And I'll just start with the basics of DBMS today. Let me share my screen. Give me a minute. Are you able to see this, guys? Guys, I just need a simple yes or no.
Yes,
Are
I
you
can
able to
see it.
see? Yeah. So, DBMS, as you all know, stands for Database Management System. And for like proceeding to the week one content, before proceeding to it, we'll need to just understand some basics of DBMS, basic definitions and what it is, how it works, and like that. So we'll start with this. DBMS, as we all know, is a database management system. But what is a database? A database is, guys, nothing. It's just like we have a lot of data with us, but we can't just keep it scattered, right? We need to manage it properly in tables or in other structured forms in order to understand it properly or draw some meaningful insights from it. So that's what a database does. It is used to store data in a structured format. So as we can see, it's written over there too. A database is an organized collection of structured information or data, typically stored electronically in a computer system. So traditionally we used to store data in files, like we write used to write the data on paper and store it. But now what we do is store the data electronically in our computer systems on like hard disks and hard drives. We store data over there, and there are several applications for database management. We can store these in forms of like text files, but we can also store them in form of other databases. Proper databases applications are present nowadays in order to store these contents. So databases are mainly, guys, of two types. Number one is relational and the second one is distributed. So what is like a relational database? So relational database is like when we need to organize our data in the form of rows and tables. That is, we mainly need to organize data in rows and tables when it is like when the data is interconnected. Like one field is connected to other, and we can only draw insights from it when we like view it together in a like interconnected format. So we store them in an interconnected format too, in a format where we can view their relations. So we store them in the form of rows and tables in the rows and columns in the form of tables, and that's what a relational database does. Just store the data in the form of tables or rows and columns. Now, what is a distributed database? Distributed database is nothing like in a relational database we store the data in form of a single file, that's a table. Like we can create multiple tables, but all that is in a single file only. In distributed databases we can create multiple files. It's not a single file, we can create two files, three files, we can create like any number of files, and those are like they aren't situated on one computer, they aren't stored on a single computer or hard disk, they can be stored on multiple computers too. Okay, it can be like the location of those computers or hard disks can be same, or they can be stored across different servers across different locations. They can be scattered over different locations. So that's what a distributed database is. Now coming to the next thing, file system. For now, are you able to understand what I told you till now?
Yes, I can understand. Can you explain this file system? You can go ahead.
Yeah, sure.
Okay.
So now what's a file system? File system is nothing like, it is basically like the name says itself. It is basically a system where we store files in a structured format or in the form of like in a segregated format. Like files can be of different types, right? It can be text file, audio file, video file, and that too for different things. Like I can be working on one of some files can be related to one project, but others can be related to other project. So we store them in different folders, right? So these folders are nothing but a file system, a format to store our files. These folders in which we store our files are also known as directories. So we store the files in different directories or in different folders. We can also say that different files are grouped into different directories. So like we have a master directory. Master directory over here is like the hard disk of a computer, like local disk C. Inside that you may see there are different folders created, like program files 86. So there are different files stored in different folders. So like it's a master file directory and then a user file directory, and then we can access our files itself. Now moving forward, we come to what is actually is DBMS, the database management system. So basically it is a software that stores our data, that manages our data of like related data that is stored in the form of a collection or in a structured format. So it is what it is mainly used for, a DBMS. It is mainly used to store our data and retrieve it or access it whenever we need to. Thirdly, like we can see if we store the data traditionally in a file format. So sometimes there are chances of like we may lose our files. It may be due to we may actually lose them to something, or they may get spoiled or anything. Data may not be correct, data may not be like viewable very easily, or the readability might not be very good. So in that case, this DBMS also provides a data security. Why? Because the data is stored electronically. There is no chance of like the digits might not be uh, very much readable or anything. Although the hard disks can also be like destroyed, but the data can also be stored on the online servers too. So it provides us data security too. Data can be when we store the data in a DBMS, we know how to store it, we know how to retrieve it. But in order to store and retrieve this data, we need to like learn some particular commands or learn some particular queries. And these queries are mainly known as SQL queries, the structured query language. SQL stands for structured query language. So the data we like store or when we want to retrieve it, it can be done storing and retrieving both. Can be done using SQL queries, and it's like we may apply some conditions for like what data we need, if else type conditions like that, those we use in general, those kind of conditions only. Yeah, so we may see like the database applications, they can be used by end users. These applications are also used by database management systems which are connected to the databases themselves. Now moving forward, what is the difference between a file system and database? So in a file system, we know that this data is stored in our computer in different folders or in a storage medium in our computer only, right? In DBMS, what does DBMS do is it manages the database in which we store our data. That database can be created on a computer itself, or it can be created on an online server. Like if you may see, if you might have used it, there is a this database only that's known as MongoDB. It can be run on a computer itself, but it can also be run on the cloud. It is like using a website. So we need not store the data on a computer. Now, in file system, we may copy paste files, so the data may become redundant. That is, there may be a repetition of multiple files that contain the same data. But in a DBMS or in a database, when we enter a data, we can actually put there like a condition that the data should be unique, or we may see to it that the data is unique. So that issue might not be there. Now when we move forward, so in file management systems, like there isn't any backup or recovery of data when it is lost, but when we store our data online on a DBMS, if it is on the cloud, we can easily recover it. That's not an issue. And like as we see forward, there is the this DBMS provides more security. It is a bit complex, but it provides more security. So like we can efficiently access our data or process it. Like there are multiple benefits, and as we see mainly they are like it provides us more security. It is a bit complex, but it provides us more security. It provides us data consistency, that is our data doesn't easily get Yeah, it doesn't get updated or doesn't get hacked, doesn't get updated without a permission, and we can efficiently access it, process the data, keep backups, and there are like multiple things, multiple advantages over it. Now, as we move forward, now like we saw the file-based system. What is a file-based system? How we store data in it. And we saw the data DBMS system, like how do we store data in a database. Now you may see in a DBMS, the database management system, it may actually manage multiple databases. There isn't any condition that there will only be a single database that it can manage. It can manage multiple databases. And similarly, like a file system can create multiple folders. Now we know that database or a DBMS is a better thing than file-based system. But what is better in it? We'll just look over that once. It will hardly take a minute or two. So we'll just look at the disadvantages of the file-based system. Firstly, data redundancy, multiple copies of the same data. Secondly, inconsistent data. Like some of the copies may be updated, we might update in only one copy, but the rest are not updated. So there is inconsistency in the data format. Thirdly, data isolation. Like if we store in our computer in a file system, there may be, if you create a new application, we might not exactly specify the part to a data. It might be like isolated data may not get retrieved or anything. But in DBMS, we just need to link the DBMS once, and it can automatically like retrieve our data. Now moving forward, we see there are like integrity problems. Integrity problems are like the data might be hacked or maybe updated without a permission. But in a DBMS, when it's stored online, that cannot happen without a permission, without we access it or open the our particular profile where the data is stored. Next is security problem. Like it's just like the integrity thing only. Like everyone can access data on the computer itself, but on the cloud without an ID and password, no one can access it. And lastly, we check its concurrent access anomalies. That is, in like on the file-based system, only it once it's stored on your computer the files, so only you can access those, but none, no one other than you can access it. But when it is stored in a database, multiple users can access the data at the same point of time. Like I can access it from my PC, you can access it from your, when it is stored online in a database. So that's not an issue over there. Now we checked the types of databases, what is a file-based system, the disadvantage of file-based system. Now moving forward, we'll see what are the types of database users. Pranav, any doubt till now?
Sir, no doubt, but there is little, background disturbance with you.
Background disturbance.
Yeah, a little background disturbance.
Let me see. Give me a minute. Is it better now?
Now it's better.
Okay, okay. Yeah. So
So you can, yeah, you
now
can
we
continue.
yeah. Now we move forward to the types of database users. Firstly is the database administrator. It is like just the database admin or the person who created the database, who creates the schema. Schema is like what all fields we need in the database, what all data are we gonna enter, what is the type of data that's we gonna enter. So the database administrator is the person who like creates the database, creates the like what kind of data will need, we will enter the their type, the fields we'll enter, and the person that's the person responsible to authorize any access or like provide any access to any other person. Like if I am a database administrator, only I can provide the access to the database to you or to anyone else. So like I will be responsible for the security, and only I'll be able to provide the authorized access to anyone, like only just check or modify the database. Thirdly, I'll be monitoring the recovery backend. Like I'll be monitoring everything. If there's any issue, if there's any support you need, I'll be creating the backup of the data. If you face any error, how to recover the data, everything I'll be here to help you in that case, since I'm a database administrator. And lastly, that if there are any damages or any issues to you, I'll be the one to revert those issues and like since I'm the one creating the backup, I'll be the one to repair the data if there is any like any anomaly that got created by mistake. So that kind of thing. Secondly, is the naive or the parametric end users. That is like the people that do not have much of knowledge about the database management system or the DBMS or the database itself, but like they need to access the database of the data frequently. Like I may say, I'm someone like I'm the owner of a company, I'm the CEO of a company. I'm not a tech guy, so I need to access my website like concurrently, like every day, and I need to access like I have an admin portal or a particular login to myself where I can track all the data of the end users, like who all are using my website. I'm not a tech guy, so I do not know like what actually is a database, how to access it, how to like do anything over there. But I need to access it frequently, like to check the end users activity and everything. So here I'll be like the CEO of a company who isn't a tech guy who doesn't know much but needs to access it concurrently, the data concurrently. So that person will be the naive or the parametric end user. Next is a system analyst. System analyst is a person like um, it will be the person who like the end user that we just checked, the naive end user will be just needing to access the data. But what exactly do they need? What type of what in what format should the data be presented to them, and how should they see it, what insights they'll be getting from the data. That will be someone will need to provide them those things since they do not know much of tech. So a system analyst is a person who will analyze the data or who will process the data and provide the end data, like what the final requirement data of the end user to itself, to themselves. So system analyst will just analyze, process, and provide the data to the end user. Next is a sophisticated user. They're nothing like they're no one but just the people who access the database concurrently, just like the end user, but they also have knowledge about the database. They know how to interact with it. They know how to like fetch data or modify the data. They know how to actually work with the DBMS. So those are sophisticated users. Next, we see our database designers. They are the like the person who create the structure of the database, like how many tables should be included, what all data should be there, what all fields name and everything in the database. Like they design the entire database. These will be the name. This will be the name of database. There will be 5 tables in it. Each table will have 5 rows, 10 columns. This kind of thing. Those people are database designers. And last is application programmer. Application is programmer is like just like you and me. They are computer professionals, and they are the person who actually writes the code in order to create the database application or the database itself. They are the programmers or the backend programmers who write the code itself. Now, any doubt till now?
Sir, can you explain this? What is schema and what are the attributes?
Sure. So, like the schema, as we see, Pranav, you'll just see like when we go to buy a house. So, like when I want to construct my house by myself, I want to create a design that I want. I want to design it myself. So I'll take a piece of paper. An architect will create a design for me of the house like this. And there will be these walls. This room will be on the right side, and like in front of that room will be the kitchen. There will be the hall. So that kind of thing is done by an architect. So what an architect designs is the map or the roadmap of the house, or the what he designs is the schema of the house. Like how is the house gonna look, what things will be placed where, and how many things will be there, like how many rooms will be there. Those kind of things are done by the architect, and what he creates is a schema. So here a schema in a database is also like that only. Like schema is nothing but the thing that specifies how many tables will be there in a database. In each table, how many rows, how many columns, and what will be the name of the row or data like storing in the database. What will be the type of data will be the number, question. So these kind of things is included in a schema. Is this one clear to you?
And attributes will be like what we fill in the tables, right?
Yeah, attributes are the things
Data
that we
which is.
store in the table, the particular rows or the data
Hmm.
we store. That's attribute.
Okay. Okay.
Is it clear to you now?
Yeah.
Yeah. So we move forward now. Moving forward, we have database architecture. Database architecture is basically how a database is designed, how many levels it has. Levels, what are levels, how do you build the database, we'll see later. Like database architecture can be three types. It can be single tier, that is one tier, two tier, or three tier. These are the different database architectures. Now, what is a single tier architecture, two tier or three tier architecture? We'll go into that. So, in a single tier architecture, the like databases, I create the database, you are the user, like the end user, and you can directly access to the data. While I create the database, you can just go to a particular website and over there you can see all the data. You can access it directly. Like there isn't any person in between or any level in between you and me, the end user and the database. Any changes like you want to do can you can do directly on the database itself. There will be like there will be no one in between to like monitor what you are doing or how it is to be done or shall it be approved or not. There will not be anything like that. You can directly do. You can directly like fetch the data, modify the data, communicate with the database itself. Okay, so there's like it is gonna be you directly connected to the database itself. That is single tier architecture. In a two-tier architecture, what we do is it is basically a client server approach. Like we see in a website, client is like the front end, what we see in the website, but the server is the back end, where all the functioning is done, where the data is stored and everything. So in a two-tier architecture, the database is like at the server side. This you can see in the diagram on the left side. The database system is on the server side, but how a user will access it is through the client side only, like through the website, the front end page that they view. So the user will access through the client side. A request will be sent to the server or the backend system. Then from there, the data or from the database will be sent to the client side or to the front end, and then the user will be able to access it. So like now, between the database and the user, there's one thing in between, one level in between. That is a client server architecture or the client server level. In case we can say. So like that's two-tier architecture. There will be like us. There will be something between like two levels will be there before you can access the database. Or in order to access the database, you'll have to pass through two levels. Now, when we move to three-tier architecture, now in the single-tier architecture, you are directly able to communicate with the database. In a two-tier architecture, you are directly able to communicate with the server, and the server will communicate with the database. Okay, one level. Now we move to the three-tier architecture. Here, you cannot directly communicate with the server itself. Now, there is one more layer added between client and server. Now, what is that layer? We'll see it now. Like you can see on the diagram on the right side. Okay, you are a user. You access on the front end application or on the website. Like it is the application data or the front end. Now you want to access the database. You access it through the server. Now you go to the server. On the server, there is something different created. That's called an application server. Like you go to the server side, but over there you have to access an application, which that application will access the database now. Before the server was directly accessing the database, now the server will contact the application server and that will connect to the database. So there is like one more level added in between, that is the application server. So over there in the three-tier architecture, the user will connect to the client side one level, then it will connect to the server two levels. The server will connect to the application server three levels. Three levels between the user and the database. Are you able to understand these architectures?
Sir, can you explain the three-tier architecture? I am not able to understand that.
Not really, not really. Like you see in a single tier architecture, what we did was I'm the user, I like I contacted the database myself. Only one level, single tier. Okay. In Here, on the user, I connect to the front end first on the client side, one level, then I connect to the server. Server, two levels over, and server connects to the database. Okay, like there are two levels in between the client and the server side. Client side is one level, then it connects to server side, that is the second level. Now, in the case of 3D architecture, I am the user, I connect to the client side, client application, what I see is the front end of the website, what I see. The client application I connect to first, the client application will connect to the server, the backend server, it will connect to the backend server. Now once it connects to the backend server will connect to a new application that is an application server. Okay, so now the client server, then the main backend server. The backend server will connect to the application server that is connected to the database. The application server is now connected to the database. So like you may see over here on the right side the diagram, user first connect
Sir,
to the
can you
client.
scroll? Can you scroll little? Yeah.
Yeah. User first connects to the application client. The application client connects to the server machine or the server machine. The server machine connects to the application server now, which will connect to the database. Now there are three levels in between now. Do you get it now?
Okay. 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 So client, application client, and application server are like middle layer between database and
Yeah.
user. Something.
Yes, yes, yes.
Hmm.
Okay. Now the next thing we'll see is data abstraction. You see when I enter the data in a database system. When I enter the data in a database, I enter multiple things. But all the fields or all the data is not relevant to the user now, the end user. Suppose I enter the data, if I fill a Google form, my data is going to the backend or some database storage system. Now in that thing, there are multiple fields that I fill in a Google form. And there are some more things that go on the backend. That is my email ID that I used, the time that I filled the form, the date on which I filled the form. So these are like irrelevant fields that are not going to be very helpful to the end user. They do not need to access them. So in that case, what we here follow is the concept of data abstraction. Data abstraction means like we'll be hiding the unwanted or irrelevant details, like the details that aren't any of any use to the end user. Will hide those irrelevant details and just process the data and then provide to the user. So it will provide a different view to the user, and it will be like enhancing the security of the data. No, you do not need to provide all the information to everyone, because if we provide all the information to everyone, that info can be exploited, can be misused. So now we have different levels of abstraction. The data abstraction that we are going to do, we have different levels of it. Mainly there are three levels. Firstly is the physical level. This is the lowest level of data abstraction. What we do in this is we store the data on the database system, and over there, I'm sorry, the data is stored in like the tables. The tables we like just access using some methods or like some commands, the SQL queries in the database. It is like just like for example, if we check our customers info is stored in tables. Data is stored in the form of blocks of storage such as bytes or gigabytes. What it means is the customer's info stored at backend in the form of table, and that table is gonna be stored in the in the machine or in the storage in the form of some memory. Now it will acquire some memory, some bytes or some gigabytes of memory in the storage, some blocks of storage. So there is gonna be like just physical abstraction, like I store it in table, but the table is actually stored in the storage machine. Now the customer do not need to know that it is actually stored in the storage machine in the form of some bytes or gigabytes. Then it converts to the tables, um, and then the tables are viewed to them. They do not need to know the complete thing. They just need to view the data in the tables. So we hide this thing, the physical layer, how they are stored. We hide this thing. This is physical abstraction, physical data abstraction. Now what we are going to see is logical data abstraction. What is it? In the logical data abstraction, it describes like what data is stored in the database and what relationships among those data. Like we see in physical abstraction we hid where the data is stored or how it is stored. Now in logical abstraction we won't tell them how it is stored. We definitely not tell them this. But other than this, what we'll hide is we do not need to tell them like if I see a student recording we see in schools or in colleges. What happens is in the schools and colleges, a student's data is stored. What they stores is their name, phone number, address, the subjects that they are studying. But we know that the name is connected to the phone number, or using the name they can, or there is also a like roll number. Now we do not need to tell everyone na ki using your roll number everything like everything related to you can be accessed because roll number is unique. So like using roll number everything can be accessed. We need not tell everyone the relationship between roll number and the other fields. Like roll number is connected to your name, roll number is connected to your phone number, it is connected to your address. We need not tell this to everyone. So we hide the relationship between things or the data or the fields or the columns. Did you get this? The physical and logical abstraction.
Yes, sir.
Okay. So now the last level of abstraction is the view level. Okay. Okay, sorry. So the view level of abstraction is like till now what we did was we were presenting the data to the user in the form of tables or anything, right? But now what we see is we cannot be like do not need to provide them a, like do this key. They need to access a particular database application. They need to open this. Then they click on this table. Then they'll be able to see their data. Sometimes to the people who do not know how to open the application, that becomes cumbersome. They do not want to do that or like anything like this. So what we do is you see like the first example if you remember, like I'm the CEO of company, I am having my particular login. I want to see the data of end user on my website itself. Now since I'm not a tech guy, I don't want to open a different database application and everything. So we create a GUI or a user interface. That is we create a different view for them. Like they'll access through different. They do not need to access the database application or the table, but then we provided a particular view in the form of like a website or anything. That will be like a much better view for them. The view that they can understand easily. It's simply like it's meant to simplify or simplify the understanding of the user of the interaction with the user of the database. Is it okay? Did you understand this?
Yes, sir. Sir, your voice is not, clear, that clear.
No. Is it not clear still now? Is it still not
Now
clear?
it's clear. Now it's clear. That time it was
Okay.
not clear. That much.
Okay. So now you may see a diagram for this, the data abstraction only. Like on the physical level, we hide how the data is stored. On the logical level, we hide their relationships, the like the ID, name, login, how they are related. And on the view level, we provide different views to different people. Okay, is it okay? Did you understand this till now? Till data
Yeah, yeah,
abstraction,
yeah.
is there any doubt?
Yeah, I understand, sir.
Any doubt till now about anything?
Sir, actually, I was solving the activity questions. Like, but I get a wrong. Like, in like first question of the activity 5, right? It was the question was like it was the related with the database, something that kind of question it was, and it was the answer was given like not logical level but physical level. So in that question, I was having some doubt.
You can do one thing. Share the
Hmm.
question with me, the screenshot of the question or anything, and I'll look over that. Okay, I'll look
Okay,
over
okay,
that.
sir.
I'll either reply to you on the WhatsApp directly, or will be like today's class was meant to be an introduction for everyone. So
Okay,
I'm only gonna cover till data abstraction only till today. The rest of the
okay, okay,
topics will be covering tomorrow. So what I'll do is I'll either address your doubt in tomorrow's class or I'll address it on your WhatsApp itself. Is it okay?
Yeah, sure, sir.
Okay, so for today, we'll just keep it till now until data abstraction only. On tomorrow, we'll continue after data abstraction, that is from data independence. Now, the notes that I had shared with you people covers mainly all the topics or all the questions given in the week 1 assignment. So you may easily be able to access it. You may easily be able to solve it. If you still have any doubts in the assignment questions or anything, you can definitely discuss those in meetings. But you can't just someone asked on another group if we can solve all the questions of the assignments, but we cannot do that since it will just be nothing but we'll be cheating through the assignments. We're not here to do that, no. We are here to learn and discuss our doubts, right?
Okay, sir.
Okay. So whatever doubts you have, just share those doubts to me on the WhatsApp. You can share those on the group itself, or if you want on the my personal DM. Okay.
Okay, sir.
Okay. Then for now, let's end the class today here. We'll be conducting another session tomorrow. Okay. If
Sir,
you are
what will
available,
the
do
timing
join.
tomorrow?
It will be somewhere in the afternoon, around 3 to 4 p.m. I'll be
Uh,
communicating the exact time tomorrow only, but it will be somewhere around 3 to 4 p.m.
okay, okay, sir. Fine.
Okay. Okay. Thank you.